Hey there, welcome to Tech World GBA, your go-to channel for all things tech. If you love staying updated with the latest in technology, gadgets, and tutorials, you're in the right place. Today's topic is how semiconductors are made. Semiconductors are the building blocks of modern electronics, found in everything from smartphones to computers and medical devices. The process of making semiconductors is incredibly complex, involving cutting-edge technology and intricate steps. Below is a detailed breakdown of how semiconductors are made. 1. Raw material silicon extraction. The most common material used in semiconductor manufacturing is silicon. Silicon is abundant in sand, silicon dioxide, SiO2. The silicon used in semiconductors must be of very high purity. Purification. Silicon is purified to a 99.9999% level through the Czochralski process or float zone process. These processes involve heating silicon and spinning it into an ingot of monocrystalline silicon. 2. Wafer formation. Ingot slicing. The purified silicon ingot is sliced into very thin wafers using a diamond saw. These wafers are typically 200 mm or 300 mm in diameter and less than 1 mm thick, polishing. The wafers are then polished to an extremely smooth surface, free from imperfections. The quality of this surface is crucial for the subsequent steps. 3. Photolithography. This step involves printing intricate patterns on the wafer to create the microscopic circuits and transistors found in modern chips. Coating with photoresist. The wafer is coated with a light-sensitive material called photoresist. Masking. A photomask is placed over the wafer. The photomask contains the blueprint for the circuit design. The areas exposed to light through the mask will change the properties of the photoresist. Exposure. The wafer is exposed to ultraviolet light, which reacts with the photoresist in the exposed areas. Developing, the exposed photoresist is chemically washed away, leaving behind the circuit pattern on the wafer. The areas where the photoresist has been washed away are now exposed to etching processes to create the desired circuit patterns. Chemical etching involves applying a chemical solution to etch away the unprotected silicon, leaving behind the desired pattern. In some cases, dry etching is used, where plasma, a gas containing ions, etches patterns with greater precision. Doping is the process of adding impurities to the silicon to modify its electrical properties, allowing it to conduct electricity in specific ways. Ion implantation involves shooting high-energy ions, like boron or phosphorus, into the silicon in selected areas. This alters the conductivity of the silicon, creating p-type or n-type regions, which are essential for forming the p-n junctions that make transistors work. This step involves adding layers of conductive, insulating, or semiconducting material to the wafer. Chemical vapor deposition, or CVD, uses gases that react to form a solid film on the wafer surface. This is used for creating layers of materials like silicon dioxide, silicon nitride, or polysilicon. Physical vapor deposition, or PVD, physically deposits thin layers of metal like aluminum or copper to create the interconnects between transistors. After several layers are deposited and patterned, the wafer's surface can become uneven. Chemical mechanical planarization, or CMP, is used to smooth out the surface to ensure that additional layers can be added evenly. Transistors need to be connected to one another to form functioning circuits. Multiple layers of metal, such as aluminum or copper, are deposited to create the electrical interconnections between transistors. These connections allow the chip to carry out logical operations and communicate with other parts of the system. Once the semiconductor devices are fabricated on the wafer, they are cut into individual chips. The wafer is cut into individual chips using precision sawing. Each chip is placed into a protective casing that connects the internal chip to external pins or leads, enabling it to be connected to the larger electronic system. This packaging protects the chip from damage and helps with heat dissipation. After packaging, each chip undergoes extensive testing to ensure it operates as designed. Automated machines apply electrical signals to the chip and check if it behaves correctly. Chips are also tested for thermal stability to ensure they can operate without overheating. The overall process of manufacturing semiconductors is time-consuming and takes several months to complete for each wafer. It involves thousands of individual steps, each critical to ensuring that the final product performs reliably in everyday devices. The technologies used, such as extreme UV lithography and ion implantation, are at the cutting edge of physics and engineering. Don't forget to subscribe to the channel and hit the notification bell so you never miss out on any of our informative videos. And if you enjoyed this video, make sure to like, share and leave a comment below. We'd love to hear from you.